making you memorize all of these. I feel like the more you do them, the more you kind of have an idea. Like the ones from yesterday, I kind of have those memorized just from doing them yesterday because they're like, oh, if it's inside the circle, I do this, and if it's outside, I do this. Okay, it's not so bad. These are about segments intersecting and the rules about them. So these are two chords intersecting in the circle. Yesterday we talked about the angle measure. Today we're going to talk about the segment length. So yesterday we said like if we wanted to find this angle, we would take half of this arc plus this arc. Today we're going to talk about what if we want to find the segment length. And the theorem is if they intersect, then the products of the lengths of the chords are equal. So that means if we take AB times BC, it's going to equal EB times BD. Isn't that what you These are ones that maybe we won't memorize as easily, which is why you can write them down. So if you have two things intersecting in a circle, each of the little segments multiplied together equal the other two segments multiplied together. What's kind of cool about this is going to lead to some quadratic equations today, which means that we're going to factor. Maybe we're going to do the good old quadratic formula today. It's good. It's good for our brains. So, what if two secants intersect outside the circle, right? So this is inside the circle. This is outside the circle. It says, then the product of their measures of one secant segment and its external secant is equal to the product of the measures of the other secant and its external secant segment. So here's what's kind of weird about this one. This one, you're going to take the whole secant. So you're going to take AC times what's on the outside, so times AB. And that's going to be equal to AE, the whole segment, times AD. This is where it's nice to have this written down for your test. So you take the whole secant times what's on the outside equal to the whole secant times what's on the outside. Pretty strong feelings you don't want to do on And then the last one, right, the difference here now is we have a tangent and a secant. So it's kind of the same idea, but the tangent, there's no two things to multiply together, so you just multiply the tangent times itself. So jk times jk, or that would be jk squared, times, I think it's the whole thing times the outside. Yeah. So jk squared, so the tangent squared, and then it's the same thing that's up here. We take the whole segment times what's on the outside. So, on the next slide, I know they're kind of small, especially the story problems, it's going to be blurry to read. But you can fill the numbers if you could. You just want to be able to look at the problems and think about how to solve them. So obviously, seeing that they intersect on the inside, that's the first theorem. That's what's on the test that you're going to have to distinguish between. Also, you're going to have to distinguish on the test. We have a theorem that looks like this with angle measures. Don't do that. There's no angle measurement. There's segment lengths. So you're just going to set up the problem, right? So I'm going to say 8 times x. So this segment times this segment is going to be equal to this segment times this segment, which is 12. My own math. All right, set up the second one. I'm going to do it too. You're getting it. Really not. I've scared you with quadratic. This one. I mean, we're going to have to FOIL but I think the x squares are going to drop out on this one. So, same idea. If I take this segment times this segment, I have to say it's never such a bad idea to review quadratics because quadratics never go away. Every math class you take, you're going to have a quadratic show up there. That would be really a weird name. And a good review here. So over here, if I multiply this, that's just distributing, right? So that's just x squared plus 10x. Over here, right, you have to distribute everything in the first to everything in the second, or you can think of your good old FOIL method here. X times x squared. X times 2 is 2x. 4 times x is 4x. And 4 times 2 is 8. Remember when FOIL was brand new? Now it's just like, oh yeah, I'm not going to do that. So, what makes this not quadratic now is because there's an x squared on both sides, so that means we can just subtract it and it's going to cancel out. So that's what's really great, is that those are just going to cancel out, which means now it's just a linear equation that we can solve. So if I subtract the 6x over here, do you agree that that's not so bad at all now? Just 4x equals 8. X equals 2. Questions about that? I kind of did a whole lot of math in my head, so I need to show more work. Like my 2x and my 4x is 6x, so I subtracted 6x over here. That's where I got my 4x. And then I just had 8 left. I always use this here. Incorporate your fingers. Biologists often examine organisms under microscopes. The circle represents the field of view under the microscope with a diameter of 2 millimeters. Determine the length of the organism if it's located 0.25 millimeters from the bottom of the field of view. Now, near something. What do we do? It's definitely the same theorem, right? But the difference is we're missing some information. I do know that the diameter is 2 millimeters, right? Is this the diameter? Right? That would be the diameter, like the center of the view of the microscope. So if this whole thing is 2, could I find how much this segment is? Just 0.25 minus 2, which would just be 1.75, right? Take a quarter and get this out. So is this length the same as this length? I feel like it has to be in order to do this, right? Because it's right. It's right down the center, so it's going to be diameter. It's going to cut that in half. So that means whatever the organism length is, the same amount over here. So I'm going to call this x, which means this is x2. So the difference, right? Here's what's hard about math. Applied math is hard. Easy. Here's a formula. Regurgitate the formula. Plug the numbers in. That's easy math. Regurgitate. That means you just spew it back out the way it was given to you. Applied math is when you have to use what you know. Use that one formula and apply it to this problem to set up your equation. And that's why people hate story problems, but it's really where math is useful. So I can set up the equation that this side times this side, so x squared, that would just be x times x, is equal to this side times this side, which is 0.25 times 1. You think you can just measure the organ. I don't know where my calculator went. Okay. So do I just take 0.25 times 1.75 to get my answer? Yeah? My answer is 0.4375. I can square it. Square root it, right? Because that's x squared. Which would be 0.66-ish milliliters. Oh look, I think I had hidden answers here. Okay. Let's get some more exciting. Okay, so this is the two secant ones. And the formula for the two secants is we're going to take the length of the whole secant times what's on the outside and set that equal to the other whole secant times what's on the outside. So, how would I write the whole length of the secant? 8x? 8 plus x, right? Like if this was 8 and this was 12, then we would add them together. So this is 8, this plus x. So the whole thing is 8 plus x times just the outside part. So just times 8. It doesn't matter if you put the 8 in the front or 8 in the back. I like 8 in the front. And I'm going to set that equal to the other side. What's the whole length of this? 10 plus 24 is 34 times the outside part, which is just 10. So again, you know which formula to use. Make sure you know you're adding to get the whole length there. But this isn't hard algebra either once you set the problem up there. That would just be 64 plus 8x equals 340. So if I subtract 64, I get 276, which I got 34.5. Sometimes I worry that I would do something wrong and no one would tell me. Because someone at my husband's work bought it for him and 3 people had the same cup. So the guy that bought it for him made a list for it. It's such a thing. Not for the and then I just feel like that we take it to the school. The school I still think no, it's just a sermon. I think there was one at Target. I saw one at Target. Okay, ready for this one? You might have to work down on the assignment part for this one. So this is the other theorem. How do I know it's the other theorem? Because it's a tangent and a secant. So I can't do like the whole thing times just the inside, right? So if I do this one, it's just going to be 12 squared, so that's the tangent squared, and that's equal to this whole length. Would that whole length be, I could write x plus 2, but are you okay if I just write that as 2x plus 2? You okay with that? X plus x is 2x, and then I have the plus 2. That's the whole thing, times just the outside part, which is times x. So it's like LK times LJ. Remember, when you add x's, you just add them in front. Questions on where I got that from? So here's where the algebra part comes in. We're going to have an x squared in here now that doesn't cancel out with the other side. So that makes a quadratic equation. So I'm going to have 144 equals 2x squared plus 2x. When you just have an x squared and no x, you can just isolate it and take the square root of both sides. When you just have an x and not an x squared, we just get x by itself like we've been doing for years. But when you have an x squared and an x, and a number over here, that's a quadratic that you have to either factor or do the quadratic formula, or did Miss Pi teach you completing the square last year? I know she taught it this year. That's where the quadratic formula comes from, like half the middle number and you square it. That's the third method to do, and in Algebra 2 and in Pre-Calculus, we'll review all of those a lot more. But usually factoring or the quadratic formula are what people remember the most. But no matter what, when you solve a quadratic equation, step 1 is you have to get it equal to 0. So the first thing I'm going to do is subtract that 144 over. All over 2a. Okay. The real song is the song that I teach my kids when I teach it to them is do your ears hang low. I mean, do your chain hang low. That's the cool song, right? You know that song? Only there's a Barney song that's like, do your ears hang low? Do they wobble to and fro? Can you tie 'em in a knot? Can you tie 'em in a bow? You know that song? The quadratic formula. Quadratic formula song that you can use to remember is do 2a hang low under negative b plus or minus square root b squared minus 4ac. If you practice your quadratics, you will know it automatically. Do 2a hang low. Yep, we did a spin period. Every year, I sing it every year because every year we use quadratic formula in every class. So here are some options. One option is if you know your quadratic formula, right? A, B, and C, you can just plug it in. Does anyone have a suggestion of what we could do before we plug those numbers in? Yeah, this is equal to 0. So if you notice that you could divide everything in here and make your numbers smaller, you can make them smaller. But if you don't, if you want to use 2, 2, and negative 144, I promise you're going to get the same answer. You're just going to have to simplify more later. But if I see that, the first thing I'm going to do is I'm just going to divide everything by 2. The 0 divided by 2 is still 0. And I would get x squared plus x minus 72. Is that true? So here's where you can do the quadratic formula. You also could look to factor, and I'm going to do both here just to review with you because I think this is factorable as well. So factoring only works if you have nice answers, right? No decimals. So if you want to factor this, you have to think, what multiplies to give me x squared? X squared and x squared is good, right? This is like the best type of factoring problem. Always what multiplies to give you the last number that subtracts to give you the middle number. That's how FOIL works with the 1 there. So it's always what multiplies to give you this number. This is a subtraction sign, which means we're subtracting to get 1. If you're really bad at this and you're like, I'm never good at picking the two numbers, quadratic formula always works. And some people are go-to quadratic formula people. Some people are really good at this and they can just think of it right away. Grace. Oh. 8 times 9 is 72, and I could subtract 8 and 9, and I could get 1. So the answer, if I was going to factor this, would be 8 times 9. But then here's the really important part. We need that to give me a positive 1. So there's all these rules. But my advice is always think about if you put the negative in front of the 9 and a positive in front of 8, that does not give you a positive 1, right? So there's only one way it works. If you put the negative in front of the 8 and the positive in front of 9, that's going to give you a positive 1. So that's how you know that it's positive 9, negative 8. And then what do you do to find your zeros from there? Like, that's just factoring it. Yeah, like it's like you set each one equal to 0. If two things multiply to give you 0, one of them has to be 0. So that's where you can say like x minus 8 equals 0, or x plus 9 equals 0. And I promise that we should get the same answer if we did this in the quadratic formula. Factoring's a lot harder if we wouldn't have divided that 2 out. That's where you have to do, like, multiply the first and the last. Oh, that was a lot. Like, you might just want to do the quadratic formula. You could divide the 2 out. But I'm going to do this really quick just to show you, just to remind you. I'm going to use the simplified one. So I'm going to use A as 1, and B as 1, and C is negative 72. And I'm going to get negative 1 plus or minus the square root of B squared, which is just 1, minus 4 times A, which is just 1, times C, which is negative 72, all over 2 times A. I'll show you the mistake that people make is they don't want to put everything over 2A. They just want to put like this over 2A, and they don't put that over 2A. The other mistake that people make with the quadratic formula is right here with these negatives, but there's no need to make that mistake because you can just type that all into the calculator at once, like all under the radical. But I always look at my negatives. A negative times a negative is a positive, which means that should be a positive answer. 4 times 72 is 288, plus 1 is 289. So we get negative 1 plus or minus the square root of 289 over 2. If this was a decimal answer, you have to do the quadratic formula. So that's why some people just always do the quadratic formula, because factoring only works if they're nice answers. This one's really nice because the square root of 289, I believe, is 17. Is that true? Yeah. But then you have to remember what that plus or minus means. It means there's 2 answers. One with plus 17, one with minus 17, which should give us these 2 answers, because we're going to get negative 1 plus 17 divided by 2, and we're going to get negative 1 minus 17 divided by 2. And that gives me 16 over 2, which gives me 8, and negative 18 over 2, which gives me negative 9. So I thought as I was looking at this yesterday and trying to decide if I wanted to skip over this, 1, it's not that bad to do, but 2, I thought it was worthwhile to kind of just review factoring the quadratic formula. Yes, it is in fact. Oh my gosh. So for your homework here, the first one's like all the way through 20, and there's just not that many problems, which is why I gave you even and not multiple of 3, because multiple of 3, like, there's not that many problems, but this is 6.1. And I did even because, you know, you guys don't like to show work anyway, so I just think even then you have to something there. We should probably need some more work with some of these today. There's a little bit more stuff to solve, especially with the x's. And then 26 is just, like, find the error, like who's right and who's wrong. So not that bad to do, but there's definitely going to be some quadratic on top, or like 1 or 2 quadratic on there. Tomorrow we'll talk about this, and then we'll talk about equations, and we're going to do a fun little geometry. Take up some new pictures right there. Test next Wednesday. This is 10/7.